Hello and welcome to this video tutorial series on ethical communication with data. My name is Fred Lapola, a librarian at NYU Langone Health's Health Sciences Library and working with the NNLM's National Center of Data Services. Today I'm going to be walking you through some ethical considerations we might think about when we're thinking about communicating with data. By the end of this video series, you should have a sense of how you might critique different common chart designs and how they present or obscure uncertainty when it comes to our research findings. You'll be able to explain how different diverse viewpoints may be ignored or covered over with data visualization, and you'll be able to compare the benefits and drawbacks of design choices relating to simplified messages in charts. In this first video, we're going to begin by thinking, why might we communicate with data? For example, using charts and graphs. And so often we may think about data visualization as a way to provide simpler and faster explanations. For example, if we have data in a table, that might be harder to understand than just viewing a chart of the data. We may also be able to use that to detect underlying trends or to test different assumptions in our data. For example, a common use of data visualization might be to assess the normality of our data, which is to say, does the data have that nice bell curve, or does it have some sort of skew or other shape to it? And finally, we might use data visualization to convince others of our argument. So in aligning with that first point around simpler and faster communication, we might be using that to convince the reader of some underlying point that we're trying to make. In this first video, I'm going to take a deeper dive into this concept of uncertainty and error. Within the context of science, error is going to be any difference between observed values and any true values that we may assume to exist out in the world. For example, if we're working on a study that is looking at library readership rates, we might look at the average time that people check out or use different resources within our given context or within a sample of different contexts. But we might assume if we could somehow sample the entire world of library patrons, we would be getting a slightly different result than the values that we might measure in our sample. And so this difference between what we're able to observe and what's truly out there is going to be referred to as error. And again, when we talk about error, we're not using it in kind of the common usage where we're saying we're doing something wrong. It's important just to understand that basically anything that we're measuring, there's going to be some degree of error. And this could just be due to variability. So in our example with book usage or resource usage, different readers will use them for different times, and just by the inherent variability between those individuals in our sample, if we'd kept sampling over and over, we'd get different values. We might also have imprecise measures. Perhaps we're finding out this information by asking our library patrons how long they're spending with their resources. Conversely, maybe we're looking at analytics, for example, of the usage of online resources. That might be much more precise down to seconds, but also introduce other forms of imprecision. For example, users might not be actively, continuously using documents that they have open. We might also have inaccurate tools that capture our data in incorrect ways. So one thing to think about, perhaps we're thinking of a case study where we're evaluating different programs, program A, B, and C, and our library is surveying our users to rate things on a scale of 1 to 5. We might get very different data, and how we choose to think about and look at our data, we might get different pieces of information out. So we might note that the mean median of these three columns is very comparable, but we'll note that program C had very few people filling them out. Program A had a lot of high ratings, but also more low ratings, whereas program B was more consistent throughout. So it's good just to think about that sometimes things collected in data, we might be missing that underlying story, that underlying uncertainty, and that underlying variability within our data. So looking at things like the standard deviation, which is a way of standardizing or making consistent, regardless of the units, how different the different values within our columns are, may help us get a better sense of it. So here we can see because the standard deviation in A is larger than in B, we know that there was a larger range of variability between the results of people's evaluations in program A versus B. So just things to think about as we go through today's video tutorial. Now, a common issue that may arise when people are talking about data is this issue of significance. And increasingly, researchers are trying to move away from the idea of significance. Perhaps you've heard about significance in the concept of a p-value of less than 0.05, for example. And it's good just to keep in mind that a p-value is the probability that if the null hypothesis were true, that would we see results that we saw basically as far from the null hypothesis. So for example, if we were evaluating program A and B, if the true attitudes of our patrons about these programs was that they were the same, we would assume that they would be here. But if we were measuring some difference, we would want to make sure that that difference was far enough away from the null hypothesis as to be meaningful. And basically, this p-value is trying to assess, is this likely to be the case when we're looking at our data? So this is sometimes also related to alpha, this concept of the threshold of our data. And basically, what we don't want to do is think that we're in a separate group, in a different value, that we're saying that the B respondents really have a different attitude than A, but in reality, they're just on the tail end of the variability within that. So it's all just to say, when you see discussions of significance, really keep that with a grain of salt, take that with a grain of salt, and think about, do the differences really matter? Are they really meaningful between any two groups? So a common issue within our data is that there's going to be some degree of uncertainty. So we just mentioned that sometimes this uncertainty is due to the inherent variability within our data that will always be arising. So often common techniques that we might see may including things like error bars, so just saying what is the error within our data, as well as the use of things like gradients, ranges, and showing individual data points, which are called dot plots. However, studies have noted that when looking at uncertainty, really the background of the person reading it in terms of what is their comfort with statistics, what is their level of education, may vary greatly. So in this study, they found that people felt that results were much more likely to fall within the shaded portions of a bar chart, when in reality, what this error bar is telling us is that the true value is most likely to appear within the barred off portion. And these other charts show varying degrees of the same information, though again, one's ability, one's exposure to these different types of charts may impact the reader's understanding of that data. So a takeaway, when communicating with data, consider how might you provide information on uncertainty in your communication? How might you best let your reader know that there's some degree of uncertainty within the data visualization that you're providing?